Calc students, Coach H here with your Chapter 3 test review. This test review will be coming to you in 3 different sections. Our first section will just be problems 1 through 4, which are the graphing problems related to the test. All right. So as we work through this, again, feel free to go back, watch, and hopefully this will be a great resource for you. All right, with that being said, let's jump into problem number 1. All right, now, as we graph number 1, the first thing that I want us to recognize in this problem is that this problem is an exponent, right? And so think about what we know about the just the parent function of an exponential graph. So as we go about graphing this, we're going to kind of zero in on the exponent part, and that's going to help us plot some points, all right? So remember, as we go to plot points, we are going to want that x value to be -1, 0, and 1. Remember how we talked about how we want to work with easy points, easy things for us to mentally calculate. And so just thinking about, okay, what do I need to plug in for x to make this exponent a -1, right? Well, I need to plug in a -4 because a -4 plus 3 is a -1. All right, so that's then going to give me 2 to the negative first power minus 1. All right, and I know that 2 to the negative power is 1/2. So 1/2 minus 1 is going to give me a -1/2. And that's the y coordinate that I have here, right? So then I'm going to plug in 0 for my exponent, all right? Or I want to get 0 for my exponent is what I should say. So what value do I need to plug in for x there? I need to plug in a -3, all right? And that's really easy for us because anything to the 0 power, right? So if I plug in -3 plus 3, that gives us 0. 2 to the 0 power is 1, and 1 minus 1 is 0, all right? So again, easy values for us to work with. That's what we want, okay? Now I want to create an exponent of 1. So what number do I need to plug in for x to get an exponent of 1? Well, I need to plug in a -2, right? And if I take a -2, plug it in for x, -2 plus 3 is +1, right? 2 to the first power is 2. 2 minus 1 is 1. So those are the points that I'm going to plot. Now, the next thing that I'm going to graph before I start plotting my points is I want to recognize my asymptote, right? And remember, with an exponential function, the asymptote is always that vertical shift that we see here. So my asymptote in this problem is going to happen at y equals -1. Now, once again, if you just put down a -1, I am going to take points off. -1 is not an asymptote, it's just a number. Y equals a -1, that's an asymptote, okay? So I'm going to go ahead and sketch in that asymptote. I'm going to plot my points. So I have a point at -4, -1/2, so I'm about right here. I have a point at -3, 0, and I have a point at -2, 1. Okay, and then I'm going to sketch my graph. So my exponential function is looking something like this. Okay. Now let's go back and answer a few questions here. There's a couple of these other items that we need to answer that are going to be really easy for us to do, right? We know our domain, exponential functions, is always -infinity to +infinity, and we can see that in this graph. It's going to stretch forever to the left and forever to the right. The range of our graph is dependent on the asymptote, right? So the lowest this graph is going to get is approaching -1. The highest is +infinity. Need a couple intercepts, right? My x-intercept I actually know from the graphing. We actually found that through our process. So my x-intercept is going to be the point -3, 0. So the last thing that I need to find in this problem is my y-intercept. Right, now remember, to find a y-intercept, we're going to plug 0 in for x. So if we go ahead and do that, right, we get y equals 2 to the 0 plus 3 power minus 1. All right, so I just end up with 2 to the third power, which is 8. 8 minus 1 is going to give us 7. So that's my y-intercept. Again, I'm not just putting the number 7 here. That would just be a number. I need my y-intercept, which is a point. So that's going to be the point 0, 7. All right. So problem number 1 for you. graphing that first exponential function. All right, let's move on to problem number 2. Problem number 2 is a logarithmic function, right? So we want to think about what we know about the parent function of a logarithm. As we talked about solving this, we're going to kind of focus in on, again, that value of x. And we talked about 2 important numbers that we want to come up with, right? We want to create that value to be 0, right? Excuse me, not 0. We want that value to be 1, right? Because we know from our properties of logarithms that the log of any base with a value of 1, we know that that is equal to 0. So that's going to be an easy logarithm for us to work with mentally, right? Then the second value we want to work with is the base, okay? So can I make that value a base? So let's go through that same thought process, right? I want to make this set of parentheses equal to 1. So what do I need to plug in for x? Well, I need a 2. All right. So if I plug 2 in for x, I get log base 5 of 1. Again, property of logarithms tells me that log base 5 of 1 is 0. So I end up with 0 minus 4, which is just negative 4. So pretty easy logarithm for us to evaluate. And then I want to plug in a number that will give me this value to be equal to the base. My base is 5, so what do I need to plug in for x to get 5? Well, I'm going to plug in 6, right? So 6 minus 1, right? We end up with log base 5 of 5. Again, property of logarithm tells us that log base 5 of 5 is 1, and so I end up with 1 minus 4, which is going to give me a negative 3. Again, as we go to graph this, I want to think about the asymptote. With the logarithmic function, our asymptote is based on our horizontal shift, right? So we want to think about what direction is this graph shifting, and this graph is shifting 1 to the right. So that means my asymptote is going to be at x equals a positive 1. Again, we have to write that as x equals positive 1. If you just write positive 1, I'm taking a point off. So let's go ahead and graph our asymptote. Let's come in here, plot our points. So at 2, I'm at negative 4. 1, 2, 3, 4. At 6, 1, 2, 3, 4, 5, 6, I'm at negative 3. All right, and then I know this function is traveling along the asymptote, passing through my points, and off it goes, okay? Again, let's go back and answer some easy characteristics of this graph that we know. Because this is a logarithmic function, we think about our domain. The furthest to the right, or excuse me, left that it's going to go is a positive 1, and to the right, it's going to reach to infinity. So that's our domain. Our range, right, lowest this graph is going to get is negative infinity, and it's going to increase forever, so positive infinity for our range. Now let's go back and talk about the intercepts. Now in this case, as I look at this graph, as I analyze it, there is not going to be a y-intercept, right? That is not going to cross our y-axis. So I'm just going to put none. There is none. Now my x-intercept, right, to find that, I need to plug in 0 for y. So that means I got to take this logarithmic function, set it equal to 0, and I'm going to have to use some of my skills that we've covered for solving logarithmic equations to figure out what my x-intercept is. So we're going to go ahead and move forward to both sides, all right? And then after we move forward to both sides, we're going to have to change this into exponential form. So I'm just going to kind of do that all in one step. Again, add 4 to the other side, and then change it into exponential form. So I get 5 to the 4th power is equal to x minus 1. 5 to the 4th power, 5 times 5 is 25, times 5 is 125, times 5 is 625. So we end up with 625 equals x minus 1, right? And that means x is going to equal 626. Again, I don't want to write that as just a number, but I want to write that as a point. So it's the point 626, comma 0. That would be our x-intercept, okay? All right, let's continue on. Problem number 3. We have another exponential function. This is good review because we have a base that is a fractional value. But again, this is similar to problem number 1, right? We want to create values in our exponent that are easy to work with. So we want -1, 0, and 1. So as I think about this exponential function, right, I want to plug in values for x that are going to give me -1, 0, and 1. So to get a -1, I have to plug in a +2. To get 0, I have to plug in 3. And to get 1, I have to plug in 4. All right? So those are the values of x that we're going to work with, is 2, 3, and 4. So now let's go ahead and plug those exponents in. So if I plug 2 in for x, I get 1/4 to the negative first power, right? Well, remember a negative exponent, it takes a normal whole number and makes it a fraction. In this case, we already have a fraction, so it's going to kind of flip it over. And so we're just going to simply end up with 4 plus 2 as we evaluate that, which is going to give us 6, okay? And then I'm going to plug 3 in, right? Anything to the 0 power is 1. So this is really easy, even with the fractional base, right? So this becomes 1 plus 2, which is 3. And then we're going to plug 4 in. And that's going to give us 1/4 to the first power, which is just 1/4. So if we add 2 onto that, we get 2 and 1/4. All right? So now we're ready to plot this graph. Again, as we think about an exponential function, the vertical shift is going to tell us what our asymptote is. And so this asymptote is going to happen at y equals 2. So let's go ahead and draw that in. Then we'll go back, plot some points. So we're going to have the points 2, we're at 6. All right, and then at 3, we're at 3. And then at 4, we're at 2 1/4, so just barely over it. I'm going to sketch in my logarithmic, or excuse me, my exponential function. Notice that this is representing an exponential decay because this value of our base is less than 1, and so it is decreasing over time. Now let's go back, fill in some things we know, right? Start with the x-intercept. As I look at this graph, right, it's never going to cross the x-axis, so I'm going to put none down. The domain is going to be -infinity to +infinity. Again, exponential function. My range, lowest this value is going to get, is approaching a +2 and increasing to infinity. All right. Now again, we need to find a y-intercept. So we need to plug in 0 for x to find our y-intercept. So that's going to give us 1/4 to the -3 power plus 2. All right, so now again, as I think about negative exponents, right, that's going to kind of flip this, right? So it really just becomes 4 to the 3rd power plus 2. 4 times 4 is 16, times 4 is 64, plus 2, right? So my y-intercept is going to happen at 66. Makes sense as I look at this graph, right? It's going to be way above the range of the graph that we can see on our little piece of graph paper. All right, but again, represent this as a point, so my y-intercept will be the point 0, 66. Okay, and that will be our y-intercept. Okay. All right, hopefully these graphs you're feeling pretty comfortable in those, but we got one more here, so let's take a look at problem number 4, all right? Back to a logarithmic function. So again, remember when we talk about logarithms, we're analyzing this value of the logarithm, and we want to work with easy values, so we want 1 and the base again, right? And so what do I need to plug in for x to give me a value of 1? Well, I need to plug in 3. What do I need to plug in for x to give me a value of the base? The base is 3, so I need to plug in a 5, right? 5 minus 2 gives me 3. And now those are easy logarithms to evaluate based on our properties of logarithms. So if I plug in 3 for x, I get log base 3 of 1. Again, we know from our properties of exponents that that is 0. So 0 plus 1 is 1. And then I'm going to plug in 5 for x. If I plug in 5 for x, I get log base 3 of 3. Property of logarithms tells me that that is equal to 1. So 1 plus 1 is 2. All right. Now I'm going to take a look at my asymptote, right, based on that, again, horizontal shift. So in this case, we're saying, hey, x is going to equal 2. will be my horizontal asymptote, or excuse me, my vertical asymptote. So I'm going to go ahead and sketch that value in. I will plot the point 3, 1 and plot the point 5, 2. And I can sketch my graph following along my asymptote through my points, and off it goes. All right. Again, identify our characteristics. As I take a look at the y-intercept, there will not be any. There would be none. All right. Now, just a reminder from our previous problems, if you have to find a y-intercept, you're just plugging in 0 for x. Now, the tricky part for us in this problem is if we did that, right, we can't calculate that log base 3 of negative 2. First off, it's not in the domain, but even if we could, even if it was log base 3 of 2, right, we couldn't kind of do that, so you just leave it exact. But our domain is going to extend from 2 to infinity. Our range, negative infinity to positive infinity. All right, and then let's think about our x-intercept, right? Our x-intercept is going to be probably pretty close to 2, as I just analyzed that graph. I didn't draw my graph very well, but it is going to be pretty close to 2. So we know to find an x-intercept, we're just going to set this function equal to 0. So we get 0 equals log base 3 of x minus 2 plus 1. All right, so again, I'm going to move this 1 to the other side, and then I'm going to change it into exponential form. So in the process of that, I'm going to get 3 to the negative first power is equal to x minus 2. I know 3 to the negative power is 1/3 equals x minus 2. So then I'm just going to add 2 to both sides. So I'm going to end up with an x-intercept of 2 and 1/3, comma 0. And as I take a look at the picture of that, that makes sense. We're going to be really close again to the value of 2, my asymptote. And so there we go. There is the first 4 problems of your review today. I hope that this video, again, is helpful to you. Watch it as many times as you need to, and make sure, again, you're ready for that on your test. All right.